You know, when you think about the biggest leaps in human history, they don't always happen because we found new facts. Sometimes it's because we finally decided to just throw away the instruction manual. We often think the big challenge in science, especially something like astrophysics, is a lack of data. But what if the real barrier isn't a data gap at all? What if it's the weight of our own assumptions? So today, we're diving into a really radical proposal. It comes from a researcher with, well, a fascinating background, 45 years across IT, telecommunications, even quantum physics, and a one lesson from all that time, that real progress demands what they call an intellectual reset.
A hard reset.
Exactly, like wiping the hard drive clean and just looking at the raw input, without any of the old software getting in the way.
Yeah.
Now, just imagine applying that kind of system audit to the biggest information system there is, the universe. The question we're unpacking is, well, it's a little unnerving. What if our entire understanding of reality is biased by the story we've already decided is true? Okay, let's get into this.
And that's really the mission here. We're looking at this call for a total intellectual reset in cosmology. For almost a century, we've had this magnificent story, right? The Standard Model, or Lambda CDM,
Right, the Big Bang, inflation, dark matter, dark energy, all of it.
the whole grand narrative. But the idea now is to step away from that, to move beyond the comfort of the story and just look at the raw data, to establish what this researcher calls the ground truth.
And the reason for this sort of intellectual emergency, is that the Standard Model isn't just showing its age. It's starting to look like it's being held together with sticky tape.
That's a very fair way to put it. I mean,
Yeah.
the model has been incredibly robust, but now we're seeing these significant cracks, and they're not minor things, not just statistical noise. These are major anomalies that suggest the whole foundational clockwork might be off.
So let's talk about those cracks. What are the big red flags telling us this story needs a serious rewrite?
Well, the most famous one is the Hubble tension. This is a huge one. It's this persistent, growing disagreement about how fast the universe is actually expanding.
Okay. So when scientists measure the expansion rate using data from the early universe, like the cosmic microwave background, they get one number. But when they measure it locally, using supernovae in the present day, they get a totally different number.
And they don't overlap.
Not anymore. The error bars don't cross. So the two methods simply don't agree, which means our fundamental scale for the universe, our timeline, is broken.
It's like using two different yardsticks and getting two different lengths for the same room. You either don't trust the yardsticks or you don't understand the room.
Exactly. And then you have the James Webb Space Telescope, the JWST, just pouring gasoline on the fire. It's seeing these incredibly mature, fully formed galaxies so early in the universe that, according to our timeline, they just shouldn't exist yet.
These are the impossible galaxies we've been hearing about.
Right. They're too big, too structured, too soon. It's like finding a fully grown oak tree where your model says there should only be a tiny sapling. So the typical response in science when you find these uncomfortable facts is you patch the code. Or you invent a new variable to make it fit.
That's how we got dark matter and dark energy in the first place, yes. They were brilliant patches to explain things the existing laws couldn't account for.
But that's the very trap this new approach is trying to get out of.
It is, because traditional science is conservative. We'd rather add complexity, tweak a constant here, invent a new particle there, just to make the old, comfortable model fit the new data.
And the researcher's argument is that this patching is the real problem. It's theoretical bias.
Absolutely. The warning is stark, that the raw cosmic data is being cooked by a century of this bias. Our theories tell us how to interpret new data, which, surprise, just reinforces the original theory. It's a closed loop.
An interpretive loop.
Exactly. And if we keep going, we risk only ever finding what we already believe. We stop looking at the actual sky and start just admiring our own equation.
Which brings us back to that IT background. It's like a legacy system that keeps misinterpreting new data because its core assumptions are flawed. So if patching the model is the problem, how do we start over?
And that leads us to the solution, this idea of a clean room protocol for cosmology.
I love that analogy. In a lab, a clean room removes all the contaminants, all the dust. So here, the dust is our own interpretation.
That's it, exactly. And the very first step of this protocol is just this single, crucial discipline. You have to make a hard distinction between what we measure and what we assume.
Okay, let's spend a minute here because this is the real philosophical shift. We're talking about things that we think of as facts and relabeling them as just assumptions.
Precisely. Let's take the most famous example of all, redshift.
Okay.
We can directly measure redshift. We see light from distant objects, and it's stretched toward the red end of the spectrum. That is a direct physical observation, a fact,
A measurement.
a measurement. But for decades, we have automatically assumed that redshift means one thing, and only one thing, expansion. We assume the space between us and that galaxy is literally getting bigger, stretching the light wave as it travels, but that's an interpretation, an assumption.
And the model-free approach says you have to decouple those. We have to admit, okay, we measure redshift, but maybe, just maybe, it's caused by something else we haven't even thought of yet.
It is the ultimate scientific skepticism, and it applies elsewhere. We measure this incredible, uniform thermal equilibrium across the sky, the cosmic microwave background. That's a measured fact. But we immediately assume it's the afterglow of a Big Bang.
We interpret it through that story.
We do. And the classic one, dark matter. We measure gravitational anomalies, stars spinning way too fast in galaxies. That's the measurement. But we immediately assume the cause must be some invisible stuff we call dark matter.
So the goal is to stop making those leaps, to build a new foundation using only the direct observables.
The empirical axioms, as they're called, just cataloging what the universe is telling us without us telling it what it means.
And what are those axioms? The things we're allowed to keep.
They're very simple. Flux, which is brightness, frequency, or color, redshift itself, just the measurement, angular diameter, how big it looks, and temperature. That's it. That's what the photons give us.
And the big things we have to throw out are concepts like distance, age, velocity, and density.
Because those are all derived. You can't calculate distance without assuming an expansion rate, the very thing that's in question because of the Hubble tension. If you start with distance, you're already cooking the data.
Okay, I have to push on this a little. The discipline here is incredible. You're saying we have to reject all new theoretical frameworks too. What if someone comes up with a brilliant new theory tomorrow that solves everything? We just ignore it.
It's a really profound question, and it gets to the heart of the philosophy here. The argument is that any framework, even a brilliant new one, is still a set of intellectual blinkers. You're just trading one bias for another.
So you'd just be starting the same cycle over again.
You would. The universe might be trying to tell us something so completely non-intuitive that no human model we can currently imagine would even allow for it. The only way to hear that message is to have the discipline to just sit with the raw, contradictory data first.
The goal isn't a better story.
Not yet. The goal is to finish the data audit. That agnostic state is where the real value is.
Okay, so that moves us from the philosophy to the practical benefits. Why go through all this? And there are three big forward-looking reasons. And the first one, which feels so relevant right now, is about AI. It's about empowering unbiased AI discovery.
This is where that AI background really comes into play. I mean, an AI is basically a pattern recognition engine, right?
Right.
If you seeded data that's already been filtered through a human model, you're basically teaching the AI your own limitations. You're telling it what kind of patterns it's allowed to find.
You're putting it on a leash.
A very short leash. The real power comes from unsupervised machine learning. You just let the AI loose in the raw, unmanipulated data, this data deluge we're getting from Euclid and JWST, and you let it find correlations that we are literally too biased to even look for.
So it might find a pattern that doesn't fit into our four-dimensional view of physics, and a human might dismiss it as noise, but the AI wouldn't.
The AI wouldn't care. It would just report the pattern. That's the goal.
So if the AI is running free on this clean data, what's the ultimate goal? This brings us to the second reason, to discover the maximum constraint.
This is a really powerful concept. The idea is that if you look at all the clean data simultaneously without a model, you can start to see the fundamental mathematical walls of reality.
Like mapping the edges of a maze before you try to find your way through it.
That's a perfect analogy. These walls, these are the maximal constraints that any future true theory of the universe absolutely must satisfy. So we're not looking for the final answer itself. We're looking for the shape that the final answer has to fit inside.
It's forcing the universe to show its hand, to reveal its own rules.
Exactly.
And the third reason is more about the human side of science. It's to restore scientific integrity and future-proofing.
A model-free database like this would act as a kind of neutral zone for the whole scientific community, a permanent objective record of the universe, untouched by interpretation.
So different teams with rival theories.
People who believe in modified gravity versus people who believe in inflation, they can all test their ideas against the same clean, unmanipulated baseline. It gets rid of the inertia of the established story and forces a really rigorous, fair comparison.
And to do all this, to process all this data in this way, you need incredible computing power, which is where quantum computing comes in.
Absolutely. The universe is an information system, fundamentally, and quantum computers are, well, they're built for this kind of agnostic work. A classical computer would struggle with the sheer complexity, the non-local connections across cosmic scales. It would have to simplify the data, which just reintroduces bias.
But a quantum computer can handle that complexity natively.
It can map those correlations across petabytes of raw data in a way that's just not possible otherwise. They see the quantum computer as the ultimate tool for this, for finding those maximum constraints.
So it's not just a philosophical idea, it's a massive engineering project.
A huge one.
And it's not just an idea, it's a plan, a call to action. The proposal is for a 24-month sprint.
That's right. This isn't just about thinking deep thoughts. They're likening it to a Manhattan project for big data cosmology. 2 years dedicated to data ingestion and audit, to building this clean, model-free repository.
The biggest challenge in that sprint must be what you called uncooking the signals.
That is the hardest, most tedious part.
Right.
It means taking all the public data from Planck, Hubble, JWST, Euclid, and doing a kind of forensic audit on it.
You have to go backwards through their process and pipelines.
Exactly. You have to trace it all the way back to make sure the numbers reflect the actual photons the sensor caught, not some value that's been adjusted or averaged by software that was designed to make the data fit a pre-existing curve.
And that whole process, that cleaning of every single signal, is really the core of it. It's about applying what we've learned from AI to the universe itself. The ability to process new information without being blinded by the past. So this whole deep dive really comes down to this, a commitment to the end of assumption. It's not about finding a better story. It's about finding the truth that exists before any story begins, the beginning of discovery.
And this raises a really important question for you, the listener, to think about. If redshift isn't only caused by cosmic expansion, if we truly allow for other possibilities, what fundamental piece of physics might we find? I mean, could it be some subtle interaction we've never seen? A property of light itself we don't understand?
It makes you wonder, doesn't it, how much of our own knowledge, in your job, in your life, is based on data that was already cooked by some bias before you even saw it? What does it all mean? It means the universe is out there, just waiting patiently for us to finally ask the right questions in the right, unbiased way.